All right, so for those of you who missed today's class, I want you to jump right in and pause the video and work through the activity on your own first, and then you can come back and debrief the assignment all together on the video. So pause and jump in. All right, so what I want to kind of talk about here first is that hopefully when you started to type your data into your Statlet or into your graphing calculator, when we think about the year, it's important here that there's a variety of ways you could have typed this in. So some of you may have actually typed in the entire year, 2007, 2008. But what I chose to do was I basically chose to allow my years to start. So my time zero, so to speak, would be the year 2000. So for this year, I typed in 7. So you can see that my years start there, and obviously 2008, 2009, moving on. So you can see I've labeled my axis accordingly, the year since the year 2000, okay? So be careful there. You're not necessarily wrong if you go with 2007 or 2008 and you include the whole thing. You will notice that some of our answers will be different, but it's just important that you understand that and interpret it likewise. So moving quickly through here, number 1 asks us to create the scatter plot. So I've done that. You can see our scatter plot here on that right-hand side. And then when we describe the form, really, I'm just going to say for now that it is non-linear. And I'm maybe saying, well, could it be exponential, right? You guys know what exponential functions look like. So maybe it's exponential, okay? So that's something to consider there. But then number 3 asks us to calculate the least squares regression line. And so you can do that whether that's in your calculator or on the Statlet. And when you do that, it gives us our equation right here. So remember, this is y hat equals, in this case, negative 12.6328 plus 1.605x. But it's very important, we want to reiterate this again, we talked about this last class, is to make sure you define your variables. We need to know what x and y hat represent. So x in this case is the number of years since the year 2000. And then y hat is the predicted, that's not the actual, they are the predicted number of units sold. So number of our iPhone units sold in millions. And you can see that going back up to the top, I've got the least squares regression line graphed here, and you can see how it follows our scatter plot to some degree. Okay, so then we move into this idea of the residuals. And so we use our equation, our least squares regression line, to calculate our residuals. You can see how I've plugged in, we've gotten our answer, and then a reminder about how to calculate a residual. It's the observed value minus the predicted value. So our observed value for the number of iPhone units sold was 0.5 million in 2007, but our prediction was actually negative 1.3978. So that leaves me with a positive residual of 1.8978. So I really want you to think about the fact that this is positive. Because it's positive, that tells me something. That tells me here that my prediction was too low. All right. So important to remember that the positive or negative on your residual communicates some information. So it is too low. And how low was it? It was too low by 1.8978 million iPhones. So whether your residual is positive or negative is an important thing to really remember. Okay. Moving forward into number 5, this definitely required a little bit of work here to fill in your table. And then once you filled in your table by just plugging all of our years, so 7, 8, 9, 10, we plug these values into our regression line and it gives our predicted. So these are all of our y hat values. These were the actual values. And then to get the residual, you simply take the actual minus the predicted. So we already did that for the first one, and that gives us all of our residuals here. So I'm going to briefly pause while I fill those in, and then we'll keep the conversation going. So now that my residual plot is all filled in, I want to point out a few things that are important here. The first is that this line here in the middle, right, this line going down the middle, this is my y equals 0 line, right? And so that line should always be in the middle of my residual plot, okay? And so then you'll notice that we have some of our residuals I have in green are above, and some of our residuals are below. So that's our positive and our negative residuals, right? So our positive residuals above are the years where the actual was greater than the prediction, right? So in 2007, our actual was greater. In 2008, in 2013, 14, and 15, our actual values were greater than the predicted. But in 2009, 10, 11, and 12, the actual values were less than what we predicted them to be, which is why our residuals are negative, right? So to make that distinction is important, and you can kind of visualize it when you look at the least squares regression line. So I want to bring that back over here, and I want you to see, here's our line of regression, and if I take this and I just rotate it, then and I make it flat, well, there you go. That right there, in a sense, is very much what the residual plot is showing us. We have 2007 and 8 above, 9, 10, 2010, 2011, 2012 below, and then 13, 14, and 15 above again, right? So the least squares regression line is really communicating exactly what the residual plot is saying and vice versa, okay? Helps us understand that idea of being a greater if our prediction or our actual is greater than predicted or less than predicted. So last thing here for number 8 is to really answer the question of, well, do you think this is a good fit? Why or why not? And so what I've written here is that if we use the residual plot, we see this U shape, right? So if I draw that on here, we see kind of a U shape in our residual plot. And so because it's a U-shaped, what our conclusion is, right, that this is not a good fit for the data. So our takeaway, I want you to write these two takeaways down, is that if the residual plot has a clear pattern, like what we have right here, this U shape, then the linear model is not appropriate. The linear model is not appropriate. But if there is no clear pattern, and it's just kind of a bit random, then it's important that we understand that yes, the linear model is appropriate, okay? So a couple things to talk about there, but really you're looking for a pattern in your residual plot. If you have a clear pattern, then don't go with the linear model. If there is no clear pattern, go with the linear model. All right, so moving in last but not least to our important ideas, we just have 3 main things we want to highlight here. The actual residual plot, what a residual plot is. It plots those residuals of explanatory variables and their predicted response values. It helps us to investigate the appropriateness. So you can see 2 different residual plots here. This one is basically random. There's no pattern there. So that's evidence of a linear association. And this one has a pattern, that U shape again. So that's evidence of a nonlinear association between the variables. So that's important that we identify those 3 important ideas here. Go ahead and pause and try to check your understanding, and then I'm going to reveal those answers for you. All right, so for the check your understanding, we're looking at body weight and how that's related to backpack weight. So you hopefully took your data and plugged this in, whether you used a Staplet or the graphing calculator. So there's my line of least squares regression line with my variables defined. I've got my residual plot, and I've then said, you know what, the residual plot has no clear pattern, so yes, linear is appropriate. I want to very quickly show you how to do this in your graphing calculator. So I'm just going to, if you're good, you can jump off. But if you want to see how to do the graphing calculator, finish this video out. I've already got my data in, so stat and edit. My data is already typed in. But to get my least squares regression line, I press stat again. I go over to calc. And then if you notice, there's our format down there. We're using the A plus BX form. So we're going to go down to line 8, or just click the number 8, it would be fine. And then make sure that you have L1 and L2 selected. That's important. And so you can go down to enter and click calculate. Now, that gives us our least squares regression line. There's my A value, my B value, just like I already have. It also gives you your R, your correlation that we've been talking about. It's important that if you don't have your diagnostics turned on, that you do that. So let me know if you need help on that. The only other thing that I want to show you here is, well, how do I get a residual plot? So to get the residual plot, we need to turn on our stat plot. So second y equals, that goes to our stat plot. I've already actually got this on, so let me show you what it would look like had it not been. So I'm going to go to my first one, hit enter. And so if it says off, go ahead and turn it on. So you want the on button to be highlighted in black. And then I'll show you what I did here. My Y list, I want that to be the residuals. So normally that is actually going to say L2. So I'll switch that back. It says L2. But what we need it to say is residual. So what we do is we press second stat. So I did that again. So second stat. And then there's number 7 says resid. So I'm just going to click 7. That changes. Oh, we got to get rid of the L2. Let me delete that. Okay, let's do that one more time just to make sure we're good. So second stat, number 7. Now we got our residuals in. My type is the scatter plot right here, the very first one. And so to view this, we click zoom, and then this is zoom 9 for zoom stat. So zoom 9, there is my residual plot. So you can see I've already got that screenshotted in to the check your understanding. Okay, so hopefully that helps you navigate the work a little bit better on your TI-84 as well. Keep up the good work, and we'll see you soon.